So we have to be able to test a model, but we have to be able to test a fact too, right?
Now you're on the right track. In the context of science, a fact must therefore be something that anyone can verify for himself or herself, at least in principle. So, even though the interpretation may be different, some interpretation of the sun is there every morning, and that can be verified. Then a model is proposed to explain the facts. And a model is
An explanation of the facts.
right. Once the facts have been observed, a model can be proposed to explain them and not only explain what's obvious, but also make predictions that can be tested through further observations or experiments. Let's go back to Ptolemy's model of the universe, which assumed that the Earth was the center of everything. Okay, that was a useful model because it predicted future locations of the sun, moon, and planets in the sky. However, although the Ptolemaic model remained in use for nearly 1500 years, eventually it became clear that its predictions didn't quite match actual observations, a key reason why the Earth centered model of the universe finally was discarded.
So models are discarded when they don't match the observations.
Exactly, and new models are proposed to explain the facts in a better or more inclusive way. Okay, how does a model achieve the status of a theory?
Well, I guess sometimes the model doesn't fail. It gets repeated by many experiments, and the predictions are verified.
So, when a prediction is verified, repeated, then we start to assume that the model is a valid representation of nature. And when that happens, with many experiments and a number of different researchers, then the model achieves the status of a scientific theory.
But,
Yes, Jerry?
well, the problem is that theories get discarded too, don't they?
Absolutely. Because it isn't really possible to prove that a theory is true beyond all shadow of a doubt. And that's good because doubt is a cornerstone of science. Even a well researched and presented theory should undergo continuous challenges from the scientific community with further observations and experiments.
I'm sorry. Did we mention the term hypothesis? Does that fit in with a model or a theory?
Glad you brought that up. A proposed model is often called a hypothesis, and that just means that the scientist is making an educated guess that the model's predictions will bear up under testing.
So a hypothesis is a proposed model.
Right. But let's put this all together, shall we? Step one's observation, the collection of data, that is, observations. Step two's hypothesis, or a model to explain the facts and to make predictions. Step three's additional observations and experiments. And here's the important part. When the predictions fail, then we recognize that the model's flawed, and we have to revise or discard it. But when the predictions are verified on a consistent basis, then we consider the possibility that we have a true representation of nature, and we elevate the model to the status of a theory.
So step 4 is the theory?
Right. But even then, the theory must undergo step 5. That's further observations, experiments, and challenges. Okay so far? Okay. Now, for a reality check. In the real world of science, discoveries are rarely made by a process as mechanical as the idealized scientific method outlined in your textbook, the one that we just summarized. For example, anyone recognize the name Johannes Kepler?
Sure, didn't he propose the laws of planetary motion?
He did, in about 1600. But instead of verifying new predictions on the basis of his model, he tested the model against observations that had been made previously. And like most scientific discoveries, Kepler's work involved intuition, collaboration with others, moments of insight, and luck. And eventually, other scientists made a lot of observations to verify the planetary positions predicted by his model.
Then,
So
go ahead.
the scientific method in the book, that's not really the way it happens a lot of the time.
Okay, let's
Okay,
put it
alright,
this way.
so this way.
The scientific method is a process that we need to keep in mind as we do the work of scientists.
science.
But we should
But
also
we should also
understand that
understand
it's an
that this
idealized
is the
process for
idealized
making
process for
objective
making
judgments
objective
about whether a
judgment
proposed model of nature is close to the truth. And we should also keep in mind that in the work of scientists, other factors are also brought to bear on those ideal steps in the process.
concepts of power and authority are related, but they're not the same. Power is the ability to exercise influence and control over others. And this can be observed on every level of society, from where
society. Well, today's a lucky day.